All right, let's take a look at number 3. So we just finished number 2. We're finding the angle theta given the function value using inverse properties. All right, let's take a look at number 3. The same directions, we want to find the acute angle theta. And the key word is finding the exact angle theta. So we shouldn't need a calculator involved. We shouldn't have to do any rounding. We want to find the exact. And with that said, we're involving some of our special angles as we look at these exact values. So it says sine of theta holds a value of square root of 3 over 2. And you might already know your angle theta value based off that. But again, sine, if you think back to our unit circle, that'd be an easy way to look at this one if you've forgotten your function values, which you should know this one looking at it. We talked about at the beginning of the semester. But with that said, I can easily show my unit circle involved. And we've been using our unit circle throughout the semester. But sine, you remember in the unit circle, sine's evaluated by the y-coordinate, right, with your point on the unit circle. So with a unit circle, the y-coordinate defines sine. So if you look at your unit circle, let's bring it up here. All right, we'll pull it up here real quick. You can see here on the unit circle, at 6 degrees, and here's our special angle. Rotation 6 degrees puts us as this ordered pair of the unit circle of 1/2 square root of 3/2, right, which we've proven with right triangles. But with that said, when we have our ordered pair on the unit circle, we know the function value. So that implies the sine of 60 degrees is equal to the square root of 3 over 2, right? It's equal to the y-coordinate. Right, just like the cosine of 60 is equal to 1/2. The tangent of 60 is square root of 3/2 over 1/2, right? You divide y and x. So remember your definitions on the unit circle. So we can write them up here at the top. Right, sine of theta is equal to y-coordinate. We know the cosine of theta is equal to the x-coordinate. And we know the tangent of theta is equal to y-coordinate over x-coordinate. And of course, the reciprocals of those. So cosecant, secant, cotangent would be the reciprocals. So like cosecant would be 1 over y-coordinate, right? Cosine and secant would be 1 over x-coordinate. Cotangent would be x over y. So again, remember that definition with the unit circle. So we can use that to help us. If you want, we can put our reciprocal definitions right here beside it. So again, cosecant of theta is 1 over the y-coordinate. And again, secant of theta is 1 over the x-coordinate. And cotangent, right, is x over y. Right, x-coordinate over y-coordinate. But back to our problem on our review. It says sine of what angle theta holds the value of square root of 3 over 2. So yeah, we know the angle of theta. Theta is 60 degrees. So let's go back to our problem. So we're looking here on this one. So theta, so on the unit circle, again, we know theta is equal to 60 degrees. Yeah, on the unit circle, the ordered pair at 6 degrees, and we can write it back down here. It's 1/2 square root of 3/2. Right, there's the x and the y coordinate. Again, sine is evaluated by the y coordinate. So again, there's our answer. So that was an easy one, right? We're dealing with our special angles. Now again, if you wanted to, you can put it in your calculator. So if you want to pull up your calculator, we can still use inverse properties. What's second sine of 60? Of square root of 3 over 2. So let's put in the square root of 3 over 2. Which again is going to give us, what? 60. So we don't need a calculator, but again, we could use inverses to show it. Right? And that gives us that to us. All right, let's move on. Let's solve a right triangle. It says here to solve the following triangle, and it's a right triangle with a 90-degree angle in it. We've got sides of length A, B, and C, and of course angles, capital letters denote the angles, A, B, C, standard lettering. With that said, they give us half the information. They give us angle C, they give us the 90-degree angle. They also give us angle B, it's 20.1 degrees. And they give us side C, and side C is 29.6 units in length. So we'll go ahead and label in our given information. Get a picture of what we have in front of us. So with that said, we've got half of it, right? They give you half triangle, and they've got to give you half. And they've got to give you at least one side in order to solve it. They've done that. So we're missing 3 parts, right? There's 3 things that we're looking for in this problem. We need side A, of course we need angle A, and side B. And that's our work, right? We want to know what angle A equals. We want to know what side A is equal to. We want to know what side B is equal to. Well, right off the bat, let's go ahead and talk about angle A. If we know 2 of the 3 angles, we know from geometry, in a triangle, all 3 angles add up to 180. So to find A, we just got to find the sum of the 2 angles we have and subtract it from 180. So angle C, which is 9 degrees, plus angle B, which is 20.1 degrees. Right? So with that said, we have 180 degrees minus 110.1 degrees. Right? Which is equal to what? 69.9 degrees. So our third angle, right, angle A, going to have to be a measure of 69.9 degrees, right, based off the other 2. All 3 must add up to 180. So there's angle A, right? As we're looking at our triangle, we found 1/3 of our solution. All right, well, let's move on. So we found A. Let's go get side A now. So to find side A, I'm going to use my definition of cosine. I'm going to introduce one of my definitions from right triangles. We were given angle B, right, and we were given side C. So let's use that information to help us. So if you notice, side A is the adjacent side, right, to angle B. That's the adjacent side to B. So let's use cosine. So cosine of 20.1 degrees is equal to A divided by what? Adjacent over hypotenuse. So there's our definition, right, from right triangles. And then we've got what? A simple equation to go solve now. So now we can go solve for A, right? Solving a linear equation. Got to get rid of the coefficient. So we go multiply both sides by 29.6. As we do that, of course, they divide out. And we got what? A equal to 29.6 times the cosine of 20.1 degrees. And it says find all your sides and angles to the nearest tenth. So we go to our calculator and plug that in, see what we get. So let's plug in and see what we have on that one. So 29.6 times the cosine of 20.1 degrees, and we are in degree mode, we get 27.8 rounded to the nearest tenth. So A is approximately, again, let's say rounded number, it's approximately 27.8 units in length. So there's one of the 2 missing sides, right, using cosine. Now we could, if we want, at this point we could use a Pythagorean theorem, right? Now that we know 2 or 3 sides, and we could find the other side. All right, what I want to do, just to be different, I'm going to use my trig functions, just for a good review. Let's go back to the angle here of angle B, beta, or B I should say, not beta. We know side B, right, is the opposite, right, side for angle B. So with that said, I can go here and calculate it. So if I ask you what's the sine of angle B, 20.1 degrees, it's equal to the opposite side, which is B units in length, divided by the hypotenuse. So again, there's my definition. Opposite over hypotenuse. And then I can go solve it, right? Solve an equation, let's get rid of the coefficient. So we'll go ahead and multiply both sides by 29.6, so we can get B. And we have what? We've got B equal to 29.6 times the sine of 20.1 degrees. And again, you put that in your calculator, right? Round it to your nearest tenth. So let's go put that in. So with that, we had 29.6 times the sine of 20.1. And that gives me 10.2. Rounded. So 10.2 as we round that off, right, for side B. Right, so there's B, and again, that's all 6 parts. So we've got the 3 missing parts now found. We've solved it. So there's our solution to our triangle. All right. Moving on, let's go to problem number 5. In problem number 5, it says find the trigonometric function value of angle theta. Sine of theta is 2/13 and theta is a quad 2 angle. Find the cotangent of theta. So just to be different, just to show you different approaches, you could use right triangle trig again, right, and draw a right triangle with sine definition. Just remember your changes in sine based off quad 2. Or another approach is to look at this quad 2 angle theta. Look at the terminal side of that rotation. So that's what I want to do here, is draw a visual of this angle in quad 2. So with theta, we got a quadrant 2 angle. All right, so I'm going to go ahead and draw in a rotation here to quad 2. So here's theta. And theta's in quadrant 2. With that said, based off points on the terminal side, if you remember our definitions, right, any ordered pair on the terminal side of a rotation, sine is y coordinate, right, divided by radius. We know that cosine theta is x coordinate divided by radius, right, r. And we know that tangent of theta is y coordinate over x coordinate. And that's why in the unit circle, as we talked about earlier, sine is just y coordinate because radius is 1 unit on the unit circle. Cosine is the x coordinate. Radius 1 unit divided by 1. So with that said, when they give us the sine of angle theta, right, sine of theta holds a value of 2/13. We know the y coordinate, right, and we know the radius. So let's look at that. So let's draw a point, put my ordered pair here on the terminal side, and I'm going to label this. So we got to find the x coordinate, but I know the y coordinate is 2. And I know the radius, we can put it in a different color. We know the distance from the vertex, right, which is angle of standard position, is the origin, to that point. That would be the radius. That's 13 units. There's the radius. So what we need, right, is we need to find the x coordinate. And we finish off this ordered pair on the terminal side, which I'm going to do that using a right triangle. All right, so we know in this point here, as we would go to that ordered pair, we go left x units and we go up 2 units, right, looking at our horizontal and vertical distance. So I'm going to go ahead and label that. So left x up 2. So again, that'll give me the ordered pair x2. So that labels the 2 legs of the right triangle. And now let's find x. So to find x, all I've got to do is use the Pythagorean theorem. So I'm going to go use Pythagorean theorem to find x. So square the hypotenuse, 13 squared, equal the sum of the squares of the 2 legs. All right, so that implies 169 equal x squared plus 4. Right? And then we solve for x, subtract 4, And that gives me what? 165 equal to x squared. And then take the square root to get x. So x is equal to the square root of 165. Now, since we're looking at a ordered pair, right, here in quad 1, we know that's going to be a negative square root of 165. We're going left square root of 165 units. So there's our x coordinate, right, for our problem. So now as we go back to the question, it said find the cotangent of theta. Well, we can find all 6 trig function values at this point. But cotangent of theta is equal to x coordinate, right, divided by y coordinate. So that's the reciprocal tangent. So that's equal to negative square root of 165 divided by the y coordinate, which is 2. And there it is. There's your function value. And that's using the ordered pair approach, right, which is proven with a right triangle, right? You can see I drew in that right triangle to show that. But again, it makes it easy to see the signs. You also, as far as the signs, positive and negative, you also remember that quadrant 1, everything is positive. Right? Quadrant 2, only thing positive is sine and cosecant. Right? In quadrant 3, the only thing positive is tangent, cotangent. Quad 4 is cosine and secant. All students take calculus. That's one of those things easy to remember, sign changes. So if you are just drawing a right triangle and you find your function value, of course everything's positive, when you're labeling your right triangles, just remember what quad you're in for the sign. This is a negative function value. But there's cotangent of theta. Right? Of course, we can find any of them, but all they ask for is cotangent. All right, let's look at number 6. It says find the exact function value if it exists. Well, exact values, we're dealing with special angles again. All right, sine of 315. Well, 315 degrees is one of our special angles. So again, this might be a good point to go back to our unit circle. So back on our unit circle, we've got, of course, 315 degrees labeled right here on our unit circle. It's our 45 degree mark in quad 4, right? It's 360 minus 315. The reference angle is 45. So you'll see it's the same coordinates, just sign changes, as our 45 degree ordered pair. So yeah, our x coordinate and our y coordinate, right, is square root 2 over 2, negative square root 2 over 2. So we know from that, right, we know that the sine, so we want to calculate the sine of 315 degrees, right, we can easily calculate that. That's equal to the y coordinate, negative square root 2 over 2. So there's our function value. So let's go ahead and put that in. So going back to our review, so sine of 315, right? So again, if we don't know, again, the sine of 45 degrees, square root 2 over 2, it's now a negative because we're in quad 4. So again, these are function values you should know by this point, but you do have a unit circle you can use for reference if you need to. But there it is, sine 315, it holds a value of negative square root of 2 over 2. How about the secant of 270? Well, the secant of 270 degrees, right? If you go back to, we can go to the unit circle again. Let's look at our unit circle again real quick. Where's 270 degrees? 270 is at our y-intercept point, here on the negative side of the y-axis on our unit circle. So we're looking at our x and y coordinates. So if I ask you what's the secant of 270 degrees, that's 1 divided by the x coordinate, right, which is 1 divided by 0. And 1 divided by 0, of course, is undefined. Does not exist. Yeah, the secant of any angle measure on the y-axis. So any rotation, right, of 90 or negative 90 or 270 or any coterminal angle with that, right? You can add a subtract multiple 360 to 90 or 270. You're right back at the same spot. Or again, looking at those undefined values. So again, that's undefined at 270. So let's go ahead and go back to our review problem. So looking at that one, yeah, that one is undefined. And again, we're going off the unit circle. So again, using our unit circle approach, right, and we can draw that over here on the side, little hint, reference here, so reviewing. So unit circle approach, we know again at 315 degrees, our ordered pair was square root 2 over 2, negative square root 2 over 2. We know here at 270 degrees, we had our ordered pair of what? 0, negative 1. So again, that's our x and our y coordinate. Again, sine is y coordinate. Right? And we know that secant, which again is 1 over the x coordinate. There's 1 over the x coordinate. Right? For that undefined. Can't have it. Now how about the tangent? Let's look at a radian measure. How about the tangent negative 5 pi over 6 radians? What's his value? Now, let's go back to, if you're not sure, pi over 6 is one of our 30-degree marks. So as we go back to our unit circle on here, and let's pull it back up. Looking at the unit circle again. Now, looking at negative 5 pi over 6, of course, we can go ahead and look at these with negative rotations. Right, there's negative pi over 6, negative 30 degrees. Here's negative pi over 4, negative 45 degrees. Here's negative 60, negative pi over 3. Here's negative pi over 2, negative 90. Right? We keep going. So here's negative 2 pi over 3. Right? Here's negative 3 pi over 4. Right? Here's negative 5 pi over 6. So negative 5 pi over 6, all right, is coterminal with 7 pi over 6. Yeah, if you take 7 pi over 6 and subtract 2 pi, you're going to get negative 5 pi over 6, right? So again, that's 7 pi over 6 minus 12 pi over 6. So again, here's negative pi right here. So we want to label that. Again, there's negative pi, negative 180. Of course, you can go all the way around and complete it, all the way around the unit circle to negative 2 pi, back to 1, 0. But here's what I needed. So if I'm looking at evaluating my trig function value, right, we want to know the tangent, right, of negative 5 pi over 6. Well, tangent is y coordinate over x coordinate. So our y coordinate, negative 1/2, divided by our x coordinate, which is negative square root 3 over 2. Right, we'll go ahead and divide those. Right, and we get our function value, and this is, of course, 1/2 times 2 over square root of 3 as I multiply by the reciprocal. Of course, the negatives, they cancel out. 2 negatives make a positive, so we end up with 1 over square root of 3. And then as we rationalize, we multiply numerator and denominator by square root of 3. I get square root of 3 over 3. So tangent of negative 5 pi over 6 holds a value of square root of 3 over 3. And again, remember, tangent is always positive in quad 3. Tan and cotan is our positive functions. So there's our function value for that one. So let's go back to our problem. We'll go ahead and write that one in here. So tangent negative 5 pi over 6 is a value of square root of 3 divided by 3. And again, if you need to over here, we can label that ordered pair, right? Negative 5 pi over 6 had an ordered pair of what? Negative square root of 3 over 2, negative 1/2. So as you're looking at tangent, right, where did that come from? That's from the y coordinate, right? Negative 1/2 divided by the x coordinate, right? Y over x, tangent's definition, which again, simplified equals square root of 3. Let's showing that. Tangent of y divided by x. So again, taking the y and x coordinates and dividing those. All right, let's look at our last one. So we've got sine, secant, and tangent. Let's go ahead and answer cosecant. And we put it over here. What's the cosecant of 5 pi over 4. What does it equal? And again, 5 pi over 4, we should know quickly, is one of our 45-degree marks. So we'll be looking at our ordered pair square root of 2 over 2, negative square root of 2 over 2, right, if we're in quad 4, we talked about earlier, or 315. But you know, again, with this one, as we're looking at 5 pi over 4, we're in quad 3. So we see our coordinates are both negative. It's a quad 3 point. So here's 5 pi over 4. So yeah, cosecant of 5 pi divided by 4 is equal to 1 divided by the x-coordinate, which is 1 divided by negative square root of 2 over 2, which equals what? So we go ahead and rationalize. We go ahead and flip. Right, multiply by the reciprocal. And then as we rationalize, we end up with negative 2 square root of 2 over 2, which is negative square root of 2. There's a cosecant of 5 pi over 4. All right, so let's go back to our review problem. So using the unit circle makes all of these quick and easy. So there's cosecants, function value of 5 pi over 4. And again, where'd that come from? We'll write down here from the ordered pair of the unit circle, negative square root of 2 over 2, negative square root of 2 over 2. Right? So cosecant again is 1 over the y-coordinate. So again, 1 divided by the y-coordinate. So it's cosecant. I think on the unit circle, did we label that incorrectly? Yeah, we did. We did cosecant. We did secant, of course, same value. Make sure we remember that is the y-coordinate. I think we mentioned x. But y-coordinate, x, of course, the same in quad 3. So with that said, again, that's just a review of unit circle approach. Right, making those problems quick and easy. And use your unit circle to help you. All right, so that's a good stopping point. We'll look at some identity review in our next few problems.